We are going to look at a very funny statement today. It's a statement that very many people dislike in different programming languages, but it occupies quite a place in C, and you'll see why. So let's say I gave you some work. I gave you a program to print the name of the day of the week. It seems very silly, and it is silly. What do? You use this if condition and you say if n equals 1, you print Monday, else if n equals 2, Tuesday, blah, blah, blah. You just do this and you have this extremely um, annoying piece of code that you've written. You can also write it in this way. Now here I have removed the indentation, but you will actually see that this code reads more naturally than what I showed you on the previous slide. On the previous slide, it looked like this, much bulkier, much less intuitive. Here, it looks much more intuitive after having removed indentation. So sometimes not indenting looks nicer. And of course, if we had put in those braces, this would have looked way uglier. So, as I have said in a different video, um, indentation and bracket use is a general principle that you should apply, but there are always going to be special cases where you will have to go with your gut feel about what makes the code look better. Having the code work is important. Having the code look good is also very important. Keep that in mind. Anyway, we have the structure with if, else if, else if, else if, etc. But it's possible to do this in a more elegant way. That more elegant way is the switch statement. What does the switch statement look like? Well, for this exact same program, what I can do is I can write this statement, switch n, then I open the braces and I say case 1. What happens when it's case 1? I print Monday and then I have this statement called break. We'll see what break means soon, but broadly, we just see that for all of these cases, we do what we were doing in the if else case. We just have an extra statement called break at the end of it. So in all of these cases, we end up printing the day of the week based on the value of n. And then we have this bracket being closed and this whole block starting from here up top down to the bottom is one valid statement in C. What it does is exactly the same thing that this code on the left is doing. Based on the value of n, it either executes this or this or this or this or this or this or this. So why is this a good way of trying to write code? Well, just compare the the semantics of what you wrote on the previous code using if else with this one. The semantics of switch case in this particular instance definitely seem to be more intuitive and easier to understand for a human examiner. And that is why switch case is useful when you're trying to use this simple logic and you don't want to use if else because it complicates your understanding of the underlying situation. Anytime you have a choice from which any of a large number of conditions or scenarios may obtain, it's a useful situation to try and apply switch. You can also apply a switch statement inside an if else statement, and you can also go vice versa. The basic structure of the switch statement is to have the keyword switch at the beginning, followed by a simple bracket that encloses an expression that has to evaluate to an integer. This is something that's important. This expression that you put in the simple bracket cannot evaluate to a float. It cannot evaluate to a double. Um, it cannot evaluate to a pointer. It has to evaluate to an integer. Otherwise, you get a problem in your compilation. And with this expression, based on the result of its evaluation, you are going to go and execute code within one of these n cases. Each of the cases has a label. The label corresponds to the expression evaluated here. So if the expression evaluates to an integer that is equivalent to label 1, then whatever statement is here is executed. And if it corresponds to a different number, then the case corresponding to that label is executed. There's also, in almost all cases, a requirement for you to put a default case where if the outcome of this expression is not captured by any of these n labels, then that default condition takes care of that particular situation. So if you get an unexpected output from your integer expression, your switch case knows what to do with it using this default expression. After all the statements that you want to execute as part of the case, you have to have this break statement. And the break statement basically means that after having executed that particular line of code, you can break out of this whole switch case block and the execution of the code can continue outside of the block. You have to be careful about the use of brackets in the same way that we had this distinction in if else, where you have the simple brackets enclosing the expression that is evaluated, and you have these curly braces enclosing all the case statements. I have already told you that this expression has to evaluate to an integer. Double and float expressions cannot be used unless you specifically typecast them to int. For relational expressions, remember that the expressions evaluate to either a 1 or a 0, which are integers, so you get a warning, but it'll still work. The labels here have to be either integers or they have to be character constants. Now, why can they be character constants? Well, you know the answer, because char and int are interchangeable in the memory of the computer. You just have that ASCII table lookup that converts that integer into a meaningful character for C, but under the hood, they are the same, which is why it is possible to use character constants. If you say, try and mix them, like try to say case A plus 2, that's not going to work. Also, labels cannot repeat. You can't have the same label on multiple cases. That will give you a compilation error. The labels can be in any order. They don't have to be 1, 2, 3. They can be in any order. And you can put any number of statements here within where I've put these ellipses. This is where you can put any number of statements. You can put formulae, you can put if else, you can even put another switch, although that would be a very complicated program indeed. But in principle, it's possible for you to enclose yet another switch here, which would have its own expression and its own curly braces with the multiple cases, and so on. Now, the way the switch statement works is that first the value of the integer expression is calculated, and then that value is compared to all the labels to see if it is equal to any one of them. If any of the labels match, then the statements next to the label are executed one after the other until the break statement is encountered. Once the break statement is encountered, the execution breaks out of the switch In case none of the labels match, then the statements next to the default case are executed and then we break. If there's no default within switch, there's no compilation error. It's just bad programming practice because then the whole block may end up doing nothing in some situations and you won't know what happened. You can say, is there some way to check if the value is less than the labels? But that was not possible because switch case only checks for equality, and that too only for integers. So you can't do checks like you can do with if else, where you can say if a is less than 3, do something. You can't say switch n and expect that a logic of less than or greater than can be executed. It strictly only checks for equality. It doesn't know how to do anything else. Before we look at some examples of how the switch case statement works, I wanted to point you to a particular aspect of the break statement that we haven't looked at so far, but we really should know about. And it's because the switch case statement behaves in a very funny manner compared to the more logical if else statement. So basically, what happens is that when Mr. C, the compiler, finds a label that matches the expression that is evaluated, it keeps executing all statements it encounters until it encounters a break. That's the logic. But what can happen is that you forget to put a break statement in front of a case, and then all statements below will also be executed, even statements that belong to other cases. This behavior is called fall through. So the control falls through all the cases where there's no break specified. The break statement is what blocks the fall from proceeding any further. So once break is encountered, Mr. C says he's done with the switch statement and he steps out of the switch statement. So the break stops Mr. C's fall. This is why, unlike with if else, where you have to have brackets, in switch case, you don't need brackets because Mr. C doesn't see them. He just sees a break. If the break is not there, he will not stop. Let's take a look at some examples, both to see how switch case works and also to see how you can use this fall through behavior in the switch case statement to your advantage when you are actually trying to write some code. So here it's a bowling situation. I just have this switch. I have already specified that the expression is simply the value of the character and the value is 65. So Mr. C will print apple because the capital A label corresponds to the integer 65, as you know from the ASCII table. And so Mr. C will simply print apple and then break out of the switch statement. Simple. Let's look at this case now. Now this is a little bit more interesting because you will see that we have multiple empty cases in this code. So we have case small a, which is empty. Then we have case capital A, which prints apple. We have case small b, case small c, and we have corresponding capital cases with some print statement. So in this situation, whether you use small a or capital A, they'll both print apple. And small b or capital B will both print banana. So you have now achieved case insensitivity by adding these three empty cases in the switch statement. Notice that the positioning of these statements is important. If you position all the small letter statements empty in together, then this behavior would not be obtained. The behavior is sensitive to how the statements are located in the code. So Because case A is empty, the control will fall through from case A and enter capital A, and it'll print apple. Likewise, with case small b, control will fall through from this case into this case and print banana and then break. And so you have used fall through to your advantage to achieve case insensitivity in this program. Here is an even more extreme example. In this case, if n is 2, 3, 4, 5, or 6, I'm going to print weekday, and if it is 1 or 7, the code is going to print weekend. Look at how this logic is implemented in switch case and contrast it with the way you would do it in if else. In if else, you would say something like, if n is greater than 1 and n is less than 7, print weekend. Else, if n is equal to 1 or n equals 7, print weekend. I'm not sure if I duplicated myself, but you know what I mean. So what we can do with switch case is we simply specify these cases 2, 3, 4, 5 empty, and we have case 6 which prints a weekday. And so if you encounter any of these cases 2, 3, 4, or 5, control will fall through until it hits case 6 where it will print a weekday and it'll break. And likewise for case 1 and case 7. And we have this default condition to handle the case where if you have a number that is entered that is not between 1 and 7, we know how to handle it, and we just print illegal day. So at the end of the day, I've shown you the switch statement, and as I promised you, it is funny. It doesn't behave the way more logical, or well, more logically semantic statements work. Now, when do you want to use switch and when do you want to use if else is sort of up to you, but I want to point you to some possible guidelines for your choice. So switch has some limitations when compared to if else. You can't test float expressions in switch. You can't use variables for case labels. It can only be integers or constant characters. It has some advantages. It is much faster in execution than if else because the compiler creates a jump table for the switch internally. In contrast, if else conditions are evaluated at runtime, and so they can be slower, especially if the conditions are complex. So now you know both, and you can even mix and match if else and switch depending on what the semantics of your program call for.